Lesson 3-5, Working with Sets. Learning targets. I will be able to write sets and identify subsets and find the complement of a set. Sets are incredibly important in courses like algebra, trigonometry, pre-calculus, calculus, and even other science and engineering classes and majors use them. So they're definitely used widely in STEM, which is science, technology, engineering, and math. An example, something you might not think about, obviously teenagers watch TV shows. They're one of the major target audiences for commercials, which is generally what pays for the TV shows. TV schedulers need to know the set of teenagers who like TV shows. And so, for instance, there might be a set of students who like Pretty Little Liars in a classroom. So we could say, we always use these curvy braces. In fact, let me rewrite that. When you make the curly brace, it's often easy to go halfway in each direction. So for instance, Jan might be a student. Kathy might be another student. So that's a set of students who watch Pretty Little Liars. I Googled these. I don't actually watch these shows, but I Googled most watched by TV shows by teenagers, and I got the following set, which itself, by the way, is a set. The set of TV shows that I got from Google: Pretty Little Liars, Teen Wolf, The Vampire Diaries, The Fosters, The Secret Life of an American Teenager. Many other choices possible. You can remind me of that in class when we talk about this. So sets are a collection of objects called elements. They come in two basic flavors, roster form and set builder notation. With roster form, we want to be able to list each element of the set separately, or indicate what would be in that set if we could list them separately. So one key piece is the squiggly line. The curvy line means the set of all. So every time you see that curly brace, it means the set of all. So here, for instance, is the set 1, 2, 3, 4. And we end the set with that same curly brace. It's the set of all 1, 2, 3, 4. That has 4 elements in the set. Sometimes we don't want to have to write out every element in the set, because even though we know what they are, there may be too many. So for instance, the set from 1 to 100, I can abbreviate this using what's known as an ellipsis. So 1, 2, 3 gives me the pattern, and then I make 3 dots, and that's called an ellipsis, and it indicates that the pattern continues in this way. So this is the set from 1 to 100. It has 100 elements in it. Sometimes we want to list even more. So this set, 1, 2, 3, dot, dot, dot. That set never ends. It means the pattern goes on forever, so that is an infinite number of elements in the set. With set builder notation, we have a little bit more detail, and so we start out with the set of all, and generally we have a variable, so that'd be the set of all x. The vertical line means such that so for example, the set of all x such that x is greater than 4 is how that is pronounced. The set of all x such that x is greater than 4. Our first example, using roster form and set builder notation. So we'll write A is the set of all natural numbers that are less than or equal to 5 in both roster form and set builder notation. So roster form I will now write as RF, and set builder notation I will write as SBN, just to save time. So the roster form of the set of all natural numbers that are less than or equal to 5. So bear in mind, natural numbers start at 1. They don't include 0, and then they keep going. So the set of natural numbers that are less than or equal to 5 would be the set of all 1, 2, 3, 4, and 5. So that would be in roster form. In set builder notation, same basic start, the curly brace, which is the set of all, but now we have the set of all x such that x is a natural number and x is greater than or equal to 5, or excuse me, less than or equal to 5. End with the curly braces. Inequalities and set builder notation is the topic of our second example. So in the second example, we're going to write the given inequality, which is negative 4x plus 5 is greater than negative 12, in set builder notation. Set builder notation. And so remember, we solve inequalities just like we're solving an equation. We use SADMEPS. We do the addition and subtraction first. The only difference is when we multiply or divide by a negative number, we switch the direction of the inequality. So my first step in this case to get the variable all by itself will be to undo the addition by subtracting. So 5 take away 5 is nothing, and I'm left with negative 4x greater than negative 12. Negative 5 makes negative 17. Divide both sides by negative 4. And we get negative 4 over negative 4 is 1. But we have divided by a negative number, so we switch the direction of the inequality. Negative 17 divided by negative 4 is 17 fourths. We always have to use set builder notation. So here would be the solution when we're writing an inequality in set notation. So set builder notation will be the set of all x such that x is less than 17 fourths. And you can see, first of all, improper fractions are fine. And the other thing is, once you solve the inequality, all you have to do is place that inequality into the last part of the set builder curly braces, and you're done. The subset of a set, very important. A lot of key ideas here. The first part is A. So actually, even before I say that, let me just write this. We name sets with capital letters. So in this case, we say A is a subset of the set B, notice they're both capitalized, if every element of A is also in B. So set A is a subset if every element of that set A is a subset of the other set, in this case set B. We write A is a subset of B with what appears to be a sideways, some would say a C, but more like a sideways U with an equal sign. It's very much like an inequality symbol, but it's for sets. And so A is a subset of B. An important fact here, note every set is a subset of itself. So for instance, A is a subset of A. So in the other direction would be the empty set or the null set. So the empty set is the set with no elements. Notation is a 0 with a line through it. And that means the set with nothing in it. Notice how there's nothing in that set. Also notice that the empty set is a subset of every set. One other thing, the empty set, the set that's actually empty with nothing in it, is not the same, for instance, as the set that has 0 in it. 0 is a thing. Even though it's the number that represents nothing, it's actually an element of the set. So the empty set doesn't have 0 in it. It doesn't have anything. Also remember to write everything that I have written, please. The universal set is the largest possible set. So it is the set with everything in it. All other sets are subsets of the universal set. The complement of a set is written this way. If U is the universal set, the complement of a set A written A prime, so that apostrophe looking thing is called a prime in our textbook. There are many other notations for complement that are used in other textbooks. In our textbook we use this prime, which looks a lot like an apostrophe. So if U is the universal set, the complement of a set A, written A prime, is the set that has no elements of A, but all other elements of U. So example 4, what is the complement of the set of integers greater than or equal to 5? So here we let A equal the set of integers greater than or equal to 5. So we start at 5, 6, 7, so we look at the pattern dot, 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 and there would be our set A. So A complement, or A prime, is going to go in the other direction. So every number that's less than 5. So that would go in the other direction, dot, dot, dot. For instance, 2, 3, 4. So it's the ellipsis, the 3 dots, can actually go to the left or the right. This just means we go 4 from the right, 4, 3, 2, all the way to negative infinity. That would be the complement of the set A.